An initial sample of 1 gram of plutonium-239 decays to 0.997156861 grams after 100 years. How long will it take the gram to decay to 1 microgram? Okay, the amount we have after t years will be equal to 1 times e to the RT, where r is the decay rate for this negative constant up there, which we have yet to find. And 1 times e to the RT is just e to the RT. Now we're told that after 100 years, so a of 100, we have e to the r times 100, that 1 gram has decayed to 0.997156861 grams. And so, if we write this in logarithmic form, or take the natural log of both sides, the natural log of e to the 100r is 100r. And that'll equal the natural log of the opposite side, which is natural log of 0.997156861. And if I divide both sides by 100, I have then solved for r. So we get that r is equal to the natural log of 0.997156861 all divided by 100. Now we know the decay rate, because the natural log of 0.99 is negative. So this will be a negative number, implying not growth but decay. And we wonder how long it will take. So we're solving for t, how long, how many years before it decays to 1 microgram. 1 microgram is 1/millionth of a gram. One millionth of a gram. Or we could write that as 10 to the negative 6. That's a little easier to work with in this form. Now we need to solve for t. So, take the natural log of both sides. The natural log of e to the RT is just RT, and that will be the natural log of 10 to the negative 6 power. But notice that we can bring that negative 6 down using the power rule for logarithms. So this could be written as r times t is equal to negative 6 times the natural log of 10. And now all I have to do is divide both sides by r. So if I divide both sides by r, I get that t is equal to this negative 6 times the natural log of 10, all divided by r. So we're dividing by r down here. So let's see what that is. So let's calculate this. The natural log of 10, first of all, times 6. And now we're dividing by this fraction, which means multiplying times 100. And then dividing by this natural log. what I get is that t is equal to 485 thousand 532.56 0576, and this is in years. So to round off to the nearest year, we'll have to round it up from 2 to 3 here. So to the nearest year, the time it takes to decay to 1 microgram is about 485,533 years. So that's how long it'll take to decay away to that extent. By the way, 1 microgram is still a fatal dose for a human. Guaranteed to give you cancer. But anyway, that's the solution to this equation.